Here are a few more examples. These examples have double bonds and triple bonds. When drawing these, for the double bond, you're just going to add a second line, wherever that happens to be. For the triple bond, the difference is you're going to draw the 4 carbons. So the 2 with the triple bond and then 1 on either side is going to be a straight line. So I'll go ahead and do this one. So I always start with that triple bond. So here's the 1, 2, 3, 4 that I have marked in the original structure. Then off on the left hand side I've got 1 more carbon, so I'll angle that one off. On the right side I have 3 individual carbons, so we've got 1, 2, 3. For the structure on the left we've got 4 carbons. The double bond is between the 2 in the middle, and the second from the left has a CH3 coming off of it. For condensed, it's no different than with all single bonds. Just count your hydrogens. So we've got a CH3. Next carbon has no hydrogens, but it does have the CH3 group. Next carbon has 1 hydrogen, and then CH3 on the end. Last one, we've got a CH3, CH2, 2 carbons with no hydrogens. Then we have another carbon with no hydrogens, and it has 3 CH3s. So I could write it like this with the 3 on the outside. I could, if I want to stick to the straight chain across, say there's 2 that are branched and then 1 more that is on the main chain. Either way is considered correct. So one way for us to easily check that you are able to read line angle structures is to ask you the chemical formula. That's what we're going to do with these structures. And then if for the alkenes, we're going to also try to decide if they're cis or trans. So let's do the first example on the left. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 carbons. Hydrogens we can go and count. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. The other thing you can do is we know that this is an alkane because it was all single bonds. So we can use that 2N plus 2. We know we've got 13 carbons, so we must have 18 hydrogens. Next one's a triple bond. The thing to remember here is that triple bond is linear. So even though it's not bent at this spot, there is a carbon there. You have to have a carbon going between a triple bond and a double bond. It can't just magically change. So there's 3 carbons, 4, 5, 6, 7, 8. So we have C8. This is an alkyne, so it should be 2N minus 2. So we should have 14 hydrogens, but let's see if we can find them. So 1, 2, 3, 4, 5, 6, 7. Don't forget the 1 on the end. This carbon has none. 8, 9, 10, 11, 12, 13, and 14. All right, go ahead and pause the video and see if you can figure out the formulas for the last 2. Do notice that this last example has 2 double bonds, so you cannot use the 2N rule. You will have to count your hydrogens. This second to last problem does have just a single double bond, 1 double bond, so you can use the 2N rule to calculate. All right, quick check. We've got 1, 2, 3, 4, 5, 6, 7, 8. So C8. 2N hydrogens means there must be 16. Go ahead and mark those real quick. There's your 16 hydrogens. Last example, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Like I said, if there's more than 1 double or more than 1 triple bond, you cannot use those general formulas. So we'll count real quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Then the other thing that this problem wants us to do is decide if our double bonds are cis or trans. So we're again going to draw that line through the double bonds. And if we circle the carbons that are attached, we have 1 on each of the double bond carbons and they are on opposite sides of the line, so this is trans. The last example, we're going to look at each double bond individually. So here's the first double bond. This one has 3 carbons coming off of it, so this is going to be neither. The one on the right, we've got 2 groups like we would need. They're on the same side, so that one would be cis. The next piece of this chapter then was naming our hydrocarbons. So here what we're going to do is we need to count our carbon atoms, and then we will have a prefix that tells us how many carbon atoms we have. Then the difference is if it's an alkane, it'll end in A-N-E. If it's an alkene, E-N-E, alkyne, Y-N-E. The other added piece is if it's an alkene, you need a number, and cis or trans if it's one of those two. Alkyne, you're also going to need a number, and that's to tell you where the double and triple bond is located. So the first example is an alkane, and there are 7 carbons, so our prefix is going to be hept. Because it's an alkane, we end in A-N-E, so it's called heptane. Next example, we've got 1, 2, 3, 4, 5, 6, 7, 8 carbons, so the prefix is going to be oct. Double bond is E-N-E. We also need to know if it's cis, trans, or neither. So if you look at the double bond, we have the 2 groups on the same side, so that is cis. Then we also need a number. So the number is the location of the double bond. So check both directions. So if I go left to right, I've got 1, 2, 3, and I hit the double bond. If I go right to left, I've got 1, 2, 3, 4, 5. You always go with the lower number. So 3 cis octene. Know that the cis and the number could be flipped. So it could say cis 3 octene as well. Go ahead and try the last 2 examples and see if you come up with the same answers that I'll show here in a second. All right, this example we've got 1, 2, 3, 4, 5, so pent. The double bond, the lowest number I can give it is 2. If I go the other direction, it would have been 3. So we've got 2 pentene. In this case, if I draw a line through the double bond, my groups are on opposite sides, so it's going to be trans. If it's neither, you would just have the number, the prefix, and the ending. Triple bond, we've got 1, 2, 3, 4, 5, 6, 7. So again, it's a hept. This time it's going to be Y-N-E because we have a triple bond. Again, we need a number, so I can give it a 2 is the lowest number. And triple bonds do not have cis or trans, that's only double bonds. So 2-heptyne is the final answer. Here's some examples going the other direction. So go ahead and pause the video and see if you can draw these structures from their names. All right, first example, 3-heptyne. So 3 tells us that the triple bond is between carbons 3 and 4. So I'm going to draw that first. Then I'm going to add 2 and 1. And then I'll add 5, 6, and 7. Yours might look a little different, but you should have 7 carbons and you should have a triple bond between 3 and 4. Next we have 2 cis-hexene. So cis, I always like to start with the double bond as well, so that I can make sure my 2 groups are coming off of the same side. So if this is carbon 2, 3, this was 1, this is 4, 5, 6 to make it a hex. Nonane, non is 9, A-N-E is single bond, so 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 trans-octene. Trans is easy because it's just like the alkane zigzagged, so I'm going to draw my 8. So 1, 2, 3, 4, 5, 6, 7, 8. Here's carbon 3, so that's where my double bond is. And if you notice, it is trans with carbons on the opposite sides. All right, a few more to practice drawing, but the new concept here was to write complete combustion reactions. So complete combustion reactions are always the hydrocarbon plus oxygen as O2, and your products will always be CO2 and water. So what's left then is to just balance your reaction. Here we're given names. That means we first need to come up with the formula for the hydrocarbon. So hexane is 6 carbons for the hex. ANE means it's the 2N plus 2. So that means we will have 14 hydrogens. I know the other reactant is always oxygen, and my products are always CO2 and water. So now if we try to balance this, we've got 6 carbons on the left, 1 on the right, so we'll put a 6 in front of the CO2. We have 14 hydrogens, 2 on the right, so I'll put a 7 in front of the H2O. Oxygens, we've got 12 plus 7 is 19. Half of 19 is 9.5. Remember, when you get a half, you multiply everything by 2 to get your final answer. So we're going to have 2 of the hexane. We will have 19 of the oxygen, 12 of the CO2, and 14 of the water. If we want to draw hexane real quick, there is your hexane structure as a line angle. Trans 2-heptene, hept is C7. Ene is 2N, so again we have 14 hydrogens. The trans and the 2 have nothing to do with the formula. Again, we'll add O2. We will make CO2 and water. Trans 2-heptene drawn. There's your hept. Double bond between carbons 2 and 3, and that is trans. Go ahead and balance this the second reaction, and then write the complete combustion for 3-octane and try to draw its structure, and then come back and check your answers. All right, balancing real quick. I already know I'm going to need to double this one. The trick to that is if half the number of hydrogens is odd, you will have to multiply everything by 2. So you can try doing that ahead of time. So if I go ahead and put the 2 here, I now have 14 carbons, so 14 CO2s. I have 28 hydrogens. This side I have 2, so I'm going to put a 14 in front to give 28. I have 14 times 2, which is 28, plus another 14 gives me 32. No, not 32. We've got 42 oxygens. So half of 42 is 21. So there's your balanced reaction. For the last one, oct is 8. YNE is 2N minus 2. So we're going to have 14 hydrogens again. Plus O2 makes CO2 and water. Again, I know the shortcut, half of 14 is odd, so I'll have to double. But let's just try it without doubling, because you don't have to catch that. So 8 carbons, 14 hydrogens means I need 7 waters. This is going to give me 16 plus 7 is 23. Half of 23 is 11 and a half. So again, we're ending up with a half. So we multiply everything by 2. And there's your coefficients for your balanced reaction for the last one. For drawing 3-octane, again, I like to start with the triple bond. It's carbon 3 and 4. So there's 2 and 1, 5, 6, 7, 8. So that's the end of the chapter slide notes. If you have any questions, please let us know.